But so now we've got this market that we're trying to hit, this user experience market. We're trying to raise the price by giving a higher perception of value. How do industrial designers do this? There are there's 3 different ways lines can come together in SolidWorks, and in nature, and in products. They can just touch, you can see the sharp knee. They can be tangent, and they can be curvature continuous. For people who use SolidWorks, I'm making a spline right here in this curvature continuous. Now, industrial designers, all right. You're back to my main screen. Good. So there's 3 types of these curves. And if you're an engineer, you can call them C0, C1, C2. We won't go into all that here. But the question is, when do you use each one? Industrial designers, one theory is they're trying to mimic nature. And if you look at nature, where does nature have these sharp C0 types of curves? They have it in things that look very sharp and aggressive. This little lizard here is trying to get people to stop eating it. That's why its scales look sharp, pointy. It's trying to say, back off. Crystal isn't really trying to say anything, but we perceive crystals as sharp. You don't really find a lot of C1 continuity in nature, not a lot of tangent continuity. That's sort of a human invention. But where you see C2 continuity in nature, and I always love using the dolphin for this, it's where things are looking smooth, elegant. In nature, it's really because of fluid properties, right? Things that are going through air or water at a high speed, they need to be very streamlined. That's why you see them in nature. But how do humans perceive them? Every time we see dolphins, we perceive them as elegant, smooth, things like that. So that's why industrial designers do these things. If you want something to look aggressive, you put a lot of C0 marks on it. And I actually didn't have to add this grrr. That was how the picture came. The person who found this car looked at it and said, that is an aggressive car, and they put that exclamation on there.
I've seen that car, and that's actually a hood sticker.
If you look at the other end, go ahead, Al.
I said I've seen that car before, and that's actually a hood sticker. The company actually put that on there.
Oh, really? Oh, that's awesome. I didn't realize that.
No, that's a joke.
I just did a Google image search for aggressive cars, and that's what came back.
Yeah,
you can feel all the sharp edges,
That was a joke.
Oh, is it? Oh, you got me out. But if you look at the C2 continuity, what does that tell us? Elegant, flowing, streamlined, right? That's why designers do those sort of things. And I'm going to show you a web page in a second. The guy who wrote the web page said, if designers don't have enough time to do a C0 or a C2, if they're really rushed, what do we get? We get a nice approximation. We get an average, a C1. Things are tangent. Doesn't really say anything. It's kind of neutral. It's a nice car, but the industrial designer whose webpage I was reading kind of considers that lazy design, where you didn't go to C0, you didn't go to C2, you just kind of made things tangent. A lot of times it's for manufacturability, but you got to think about what you're saying with the product. So in our case, consumer designers are trying to say either aggressive, bold, or smooth, elegant. That's why they make those shapes that engineers hate to manufacture, the shapes that are really, really hard to manufacture. Tangent's pretty easy to manufacture. That's why we see a lot of it. The webpage I'll have you go read if you want to learn more about this. I think it's a really nice way to categorize things. Is Google a periodic table of form. And the guy talks about, here's your C1s, here's your C0s, right? Sharp, aggressive edges. Here's your C2s, flowing, elegant designs. And everything in the middle, tangent, when you don't have enough time to do real industrial design. All right, so the designer was on a crusade to get people out of this tangent realm. He actually did something very cool on this webpage, is, I'm assuming in SolidWorks or Pro-E, made a lot of wrenches and then had them cross-pollinate the C1s, C2s, C0s. So here's our C0 wrench, very basic, kind of what it would look like in SolidWorks. Here's a C2 wrench. Okay, again, elegant, smooth. If we were sitting there in a store and we had to buy one, if we were in Home Depot and we had to choose between C2 and C2 here and C0, Al, which one do you think would be perceived as the higher quality wrench?
I would say that I would have to go with the C2 for perception.
Yeah, right? Who knows if it's actually a better wrench? But in terms of what does the human eye think is elegant, smooth, higher quality, it'd have to be one of these, not one of these C0 wrenches over here. Right? And I think it's a nice little periodic table of what he did. So is the question or chat box exploding with industrial designers cursing me out?
Not yet.
All right, good.
I like what you have to say.
All right, so that's why they do the things they do. We're going to get into in a second how do we simulate, how do we make sure that those crazy designs industrial designers make don't get broken. All right, so that's, again, periodic table of form, great little blog post to kind of categorize things. It's going to affect how I think about things for a while.